So first of all, thank you Professor Corwes and Professor Husing for the opportunity to present my master's thesis at IGMR Group. My supervisor Stefan Octavian Bezrukav and Till Rickert for their continuous support and guidance throughout the whole master's thesis duration, and all of you members of the IGMR Group for attending my master's thesis defense today. The topic for my master's thesis is fabric manipulation for grasping using deep reinforcement learning to expose a flat graspable scene in simulation. I'll begin by first introducing the problem and then defining the methodology used in this thesis work, and then laying out the results and then summarizing the whole thesis. So in introduction, I'll first present the motivation behind the work and then define the problem and lay out the objectives. In methodology, basically I'll start with first selection of relevant tools and then implementation of all of these selected tools, which would be followed by design of experiments, which is also the primary contribution of this thesis work. After this, I'll present the results or evaluation of the designed experiments, and this will be followed by future scope challenges encountered during this work and a conclusion of the overall thesis presentation. We often take for granted our ability to perform mundane tasks like opening a bottle, chopping vegetables, folding clothes, and washing dishes. Such mundane everyday tasks that we humans perform very easily on an everyday basis are actually incredibly challenging for the robots to perform. How do we make sense of this complexity? It is often said that if you truly want to understand something, then the best way is to demonstrate, to build it. And to understand the complexity of human manipulation, the best way to do is to make a robot learn the manipulation task to perform manipulation of everyday objects. This falls under the category of robot manipulation. Robot manipulation is defined as the way the robots interact with surrounding objects to achieve a desired result. And manipulation of these everyday objects like plastic bottles, clothes, rubber toys, fruits and vegetables, and sponges fall under the category of deformable object manipulation. Deformable object manipulation is particularly challenging because of two major reasons. One is unclear state representation and the other is complex nonlinear dynamics of these objects.